Bismillahirrahmanirrahim. The 7 steps of fatty acid synthesis. I would like to tell you that fatty acid synthesis require an enzyme, namely fatty acid synthase complex. This complex is a multifunctional dimeric enzyme. So each monomer will contain 7 different enzymic domains, and one of the domain is called ACP domain. What does ACP stand for? It stands for acyl carrier protein, acyl carrier protein domain. And we know that as it is an enzyme, fatty acid synthase complex, so it will be protein in nature, and protein contains amino acids. One of the amino acid is sulfur containing cysteine amino acid. So here, what is fatty acid synthase complex? This is cysteine residue of the complex along with thiol group, and this is ACP domain of this complex along with thiol group. This is the main initial you can say initial structure for fatty acid synthesis, and then all the 7 steps will proceed to form fatty acids. This is first step, acetylation. What will happen in acetylation? Acetylation, as the name indicates, it's simply addition of acetyl part of acetyl-CoA. So here is the structure of acetic acid, CH3COOH, and this is the structure of acetyl-CoA. This is acetyl part and this is CoA part. What is acetylation? It's simply addition of acetyl part of acetyl-CoA into this structure. So here you can see this part, acetyl part, is attached to the thiol group of ACP domain. The next step is transpiration. Transpiration is what? It is transfer of this acetyl part from thiol group of ACP domain to thiol group of cysteine residue of fatty acid synthase complex. So here it is so simple. The next step is malonilation. As the name indicates, it is addition of malonyl-CoA. Malonyl-CoA is a 3-carbon structure, results from carboxylation of acetyl-CoA, which is the rate limiting step of fatty acid synthesis. In the presence of ACC, acetyl-CoA carboxylase enzyme, that was the regulatory enzyme of fatty acid synthesis. So simply malonylation is addition of malonyl-CoA 3-carbon structure to what? To thiol group of ACP domain. Here the thiol group of ACP domain is free, so malonyl-CoA is attached to this thiol group. 1, 2 and 3 carbon structure. The next step is condensation. What will happen in condensation? This structure, this carbon double bond oxygen along with this oxygen will released in the form of carbon dioxide. In condensation, 1 carbon is released in the form of carbon dioxide, and this acetyl part that is being attached to thiol group of cysteine residue, it will move and getting attached to this structure of ACP domain. So here 1, 2, 3, 4. 1, 2, 3, 4 carbon structure is attached to thiol group of ACP domain. The next step is reduction. Reduction is simply addition of hydrogen. Reducing agent, which we have seen in the first part of the video, it is reducing agent is NADPH. NADPH. 2 NADPH molecules will be utilized here, and 1 hydrogen will be added to, let me show you, 1 hydrogen will be added to this carbon number 3, as it is the carbon number 1 functional group, carbon number 1, carbon 2 and carbon 3. So 1 hydrogen will be added to carbon 3 and 1 hydrogen will be added to this oxygen of the carbon number 3. So there is hydroxyl group formation on carbon 3. The structure will be simply called 3-hydroxyacyl-CoA. Okay, and the second and the next step will be dehydration. Dehydration is removal of water. Water will remove in a way that this hydroxyl group from carbon number 3 and this hydrogen from carbon number 2 will release in the form of water. So the resulting structure will contain a trans double bond, a double bond of trans configuration in between carbon 2 and carbon 3. The structure will simply called trans-2-enoyl-CoA. Trans-2-enoyl-CoA. And the last step is again reduction. Reduction is again addition of double bond using NADPH as reducing agent. 1 hydrogen will be added to this carbon number 2 and the second hydrogen to carbon number 3. Here the double bond is getting reduced, forming a saturated fatty acid. the resulting end product from these all steps is a saturated fatty acid with 4 carbon atoms. So the structure is simply called butyryl CoA. Butyryl CoA. I think the spellings are right. I'm not sure. Okay, butyryl CoA, 4 carbon structure has been formed here. So one complete pathway of the fatty acid synthesis resulting in formation of 4 carbon fatty acid. Next, what will happen? The steps 2nd to 7. Basically, there are 7 steps now. So what will happen? From transpiration to reduction, the steps repeat and resulting in formation of a 6 carbon fatty acid. And for the third time, when the cycle repeat itself, there will be formation of 8 carbon fatty acid, a fatty acid with 8 carbon fatty acid structure. Okay, and the fourth time 10 carbon fatty acid, and so on. When the cycle when the pathway repeat itself for the 7th time, you will see the formation of fatty acid with 16 carbon fatty acid, and that structure is simply called palmitic acid. Palmitic acid. So what is happening here? It is simply addition of a 2 carbon structure each time steps repeat. And from where 2 carbon come? The 2 carbon come from malonyl CoA. In the third step, where malonylation occurs, addition of malonyl CoA, and in the fourth step 1 carbon is released as carbon dioxide. So the net is addition of 2 carbon structure each time the cycle, the steps repeat. There is addition of a 2 carbon structure, so the resulting fatty acid will contain 2 carbon more than the parent fatty acid. So this is the formation of palmitic acid synthesis, which is a 16 carbon containing saturated fatty acid. This is all about fatty acid synthesis. If you have any query, do ask in comments or rewind the video. Allah Hafiz.